Hello people, today we will be talking about the law of logarithms. The first law we're going to be talking about is the power law of logarithms. The power law of logarithms deals with the exponent on a base inside a logarithmic function by taking that exponent and putting it in front of the function. So to do the following problem at the top, we would need to understand how to use the power law of logarithms, and to do that we need to understand how to derive it. So let's look at the first equation, m equals a to the power x. If we introduce the exponent n to both sides, we end up with both sides being to the power of n. Now, by taking the log base a of both sides, we end up with the following function in equation number 3. And by simplifying the right side, we can end up with log base a of m to the power n equals x times n. Now, by rearranging the first equation, we are able to understand that log base a of m is equivalent to x. Through substituting the fifth equation into the fourth equation, we get log base a of m to the power n equals n times log base a of m. Now, using this new law, we can solve the problem that was introduced in the beginning, which is 14 equals log base 10 of 12 to the power of x, and we would like to solve for x. So using our newfound law, we can take x and bring it in front of the function to get 14 equals x times log base 10 of 12. And now we are able to isolate for x by dividing both sides by log base 10 of 12. And by doing that and plotting into our calculator, we get x equals 13.
The product law of logarithm deals with the addition between two logs with the same base. For example, log base of ax plus log base of ay, according to the product law of logarithm, equals to log base of axy. So how do we arrive at this result? Let's set that m equals a to the power of x and n equals a to the power of y. So mn equals a to the power of x plus y. Now we put both sides into log base of a. For that, we can get that log base of a mn equals x plus y. And once we rearrange the two equations, we have the beginning for x and y, and then substitute them into equation number 3. We get equation number 6. Log base of a mn equals log base of a m plus log base of a n. Now, we will now use it to solve an example question. Log base of 24 3 plus log base of 24 8. Now, since we have equation number 6, we can see that this equation equals log base of 24 3 multiply 8, and that equals 20. So 3 multiply 8 equals 24. Log base of 24 equals 1. So the answer of that example question is 1.
Okay, now we're doing the quotient laws of logarithm. So the quotient law of logarithm simplifies the subtraction of like-base logarithmic functions. In order to solve the problem log base 927 minus log base 9 1 over 3 equals x, we must derive the quotient law that simplifies the subtraction of two like-base logs. Assume that m equals a to the x and that n equals a to the y. If we divide m by n, we get m divided by n equals a to the x divided by a to the y. When we divide two exponential values with the same base, we get a to the x minus y. So, if we take the log base a of both sides of the equation, m divided by n equals a to the x minus y, we get equation number 4. This can be simplified into equation number 5. Since both m and n can be expressed in terms of base a to a power of x or y respectively, we can express x as log base a of m and y as log base a of n. Through doing that, we end up with the equation 6. With this newfound law, we can easily solve the problem introduced at the beginning of my section. So if we look over to the right of the screen, we see that log base 9 of 27 minus log base 9 of 1 over 3 is equivalent to log base 9 of 27 divided by 1 divided by 3 is equal to log base 9 of 27 multiplied by 3 is equal to log base 9 of 81, which means that x is equal to 2.
Okay. Now we will be doing the change of base number. I'll be showing you how to solve this problem. Log base 350 equals solving for x. This problem can be solved using a simple manner by using change of base formula. So again, we must derive the change of base formula. For starters, assume that y equals log base a of x. Then this means that x is equal to a to the power of y. If we take the log of base of b on both sides, we get equation 3. Dividing both sides of log base b of a, we get equation 4. Substituting the first equation to the fourth equation, we get equation 5. The problem we started with, which has seemingly become very easy to solve. We can use the change of base formula to solve it, using a more convenient log base, which is 10. Log base 10 of 115 divided by log base 10 of 3 equals to x. Therefore, x is equal to 4.32.
Okay, we're on the loaded gun now. The problem is as seen on the board. We can break this problem into components to solve it more simply. The first component, using the change of base, can be simplified to log base 6 of 16. The second component can be simplified by gathering like terms and using the exponent laws to get negative log base 6 of 1 over 3. Now, solving it using the product and quotient laws, we get x equal to 4.